What's transgress?
Transgress? Don't cross the line.
It's transmuted.
Transmuted. It's like ice cube to water. Try. That's the advice of smart.
Jack, what'd you put it on?
I just said that because I couldn't think of it.
I don't remember.
That means take a place in one.
Okay, when you're
Alright,
given
let's
the
smoke that for a second.
What are you doing? Green, and then those sets.
I would never let them like that review.
Okay, alright, today, let's take a few notes. Hey, I want to do two types of problems on the board really quick, just so you can see them. I want to do one where we have to actually factor things apart, and I want to do one where it's already factored, like the ones we did yesterday. So we're going to try to pick some of the problems out of the book. That way you kind of have an understanding of what you need to do today. Okay? So that's what we're going to do. That is not yours. But
assignment?
yes, you will have an assignment. It'll be due later sometime next week. So if you don't get it done, for Monday, not a worry. Okay. So this is something I do want to assign it. Oh, thank you. So I do want to assign it, but I want to make sure that we take the time today to do some notes. If you don't get it done for Monday, no worries. It'll be due sometime next week. Okay. Okay. Does that make sense? And I think it's pretty straightforward, but the problem is we do need to know all the different pieces. We have to put it all together. Okay. All right, so I'm going to pull a couple problems from the book here. All right. So let's go through a problem like I don't want to pick one like yesterday, but I'm just going to pick one out of the book here. Let's go with. That. Okay, y equals x cubed minus 4x squared. 4x squared is up there. 4x squared. All right. Okay, so now we're going to try to do every piece of this polynomial today. Remember, we're still in that same goal that we've been doing the last couple days. I want to graph this polynomial. I want to figure out the x-intercepts, y-intercepts, the leading coefficient test, all that stuff. Now, this problem is pretty straightforward. Did they factor everything apart for me?
Okay.
So now we can go through all the normal steps. So we can do the leading coefficient test first. We can factor it for the x-intercept second. We can do the y-intercepts third. The symmetry test fourth. And then see how many times it potentially can turn for the turning point. Okay? All right, so leading coefficient test, let's start with that. And again, hopefully you have graph paper. That is for your notes, so you can draw all that stuff on there. Okay, so leading coefficient test. What are we looking for on this problem for the leading coefficient test?
Highest power.
Highest power right, which is?
3.
X to the third. And what's the number out front?
+1.
Positive 1. This is positive. That means whatever my graph is doing, it's doing it the normal. It's going the normal direction. This is a normal graph. How we draw this particular polynomial. Now, what does this mean? It's an odd graph, right? The odd power. That means that the tail is going different directions. Okay? That's for end behavior. So end behavior. If it's an odd graph, the end behavior, the tails go different directions. So for me, since this is a normal graph, right? It's normal because it's positive 1 out front. The tails are going to do something like this. They're going different directions, and that's how it always works. The left side goes down, the right side goes up. Now, if it was a negative out front, you just switch these. So that'd be a non-typical graph. Okay, we're good with the leading coefficient test. Now, if this thing was completely factored all the way apart, a bunch of parentheses everywhere, you have to like FOIL it all out to figure that out. And I did show you a shortcut yesterday how to do that. But for most people, just FOIL it, and then you can look at what the biggest term is. This item, the biggest item. Okay, we good on the first step. Step 1. So I know what the tails are. Step 2, we need to factor this. X-intercepts. intercepts, we do need to factor. So, y equals x to the third minus 4x squared. All right, say it again. Take out an x squared. Yeah. So we're going to take out an x squared. What we're left with here is an x minus 4. And now that we've factored that apart, can I go any further? It doesn't look like it. This is not a difference of squares. This thing's all by itself, so no worries. So we factored it completely apart. So what will make this thing 0? 0, okay? And what will make this 0? 4. All right, so positive 4. All right, so we figured out my two x intercepts. We have a 0 and a 4. In fact, I'm going to draw the dots there. 0 and 4. Okay, we're good with the first step. Figure that out. All right, now, second part. Now that we know that we factored apart, we have to look at multiplicity. Is it bouncing off of that number? Is it passing through the number? That's what we're checking for. So, multiplicity of the 0, what's the power on? 2. That means we're going to have to bounce off of 0. The reason why we have to bounce, it's an even power. It's a power 2, or power 4, or power 6. Even, so we have to bounce. What's the power on this parenthesis? 1. That means we're going to pass through that on the graph. So I'm already starting to get a glimpse of how this thing's working. We're bouncing off of 0, we're passing through positive 4. Okay, I'm going to stop there just for a second. Is there any questions with the two tests I've done? Pretty straightforward. Okay, I think the hardest part about some of these problems today is just the factoring. Pulling things apart, doing it correctly, knowing the parentheses. That's the hardest part, I think. Okay, y-intercepts, which this problem is pretty straightforward, it's pretty easy, but y-intercepts, and I'm going to give you that definition of y-intercepts. You just have to substitute x is equal to 0 into your problem. So if this is my function, right? This is my polynomial. Just plug in zeros into it. That's like the basic definition of the y-intercept. Well, these both turn out to be 0, so that's 0, right? In fact, you could have seen it from the graph. I did the y-axis. That's not working. Okay. Questions with how I just did that? That can work for any style. Doesn't matter if they're factored apart or if they're not. I just plug in zeros for x's, figure it out, solve it out. All right, so now that we have that, I can already get kind of a rough sketch of what this thing is looking like because I have the y-intercepts, I have the x-intercepts. The only thing I won't know is if it's symmetric, which I can tell you it's probably not, and just because of where the x-intercepts are, they're not balanced across the y-axis, and where the turning points are. We'll do those tests here in a second. But I'm going to get a rough sketch of what this thing's looking like. I'm bouncing off of 0, and I'm passing through 4. So it's looking something like that. That's what I'm thinking. Now, here's the thing. I have no idea how far this goes. I'm just drawing up just kind of a smooth graph. That's all I care about. Questions, comments with what I did there?
So if you find the x-intercept at 0, do you have to find the y-intercept?
No, exactly, because you know where it's going to be. Now, if you don't have that 0 in there, then you have to go search for it. Yeah, so that's good. That's a good idea. Right? All right. Now, symmetry test. Symmetry test, to do that, symmetry test, we have to take and you have to plug in a negative x into that problem. So it's substituting again. You have to get it to that expanded form, which is this thing. So if your problem is already factored apart, you have to multiply it all together. You have to get it to look like this before you start. So for the symmetry test, so I'm going to take out all my x's and replace them with negative x's. And it has to look like this before you start. It has to be a polynomial in normal form, not factored apart. It has to be expanded form. Okay, now doing this, power 3 with the negative sign, negative will stay there, right? And since the even power of the negative sign will cancel, like that, and this is not symmetric. Now the reason why it's not symmetric, like I can tell right now, it didn't turn into the original thing we started with. No, it wasn't the exact thing we started with, and it's not the exact opposite of what we started with either. So it's not even enough. So that's definitely not symmetric. And in fact, I can tell from the x-intercepts. No, this graph is not looking the same across the y-axis, either direction. They're not looking the same. It's very weird looking.
On the homework, do you want us to do the step
yeah, I'd like you to do the symmetry test to prove why the picture isn't perfect. So you do have to do that step. Okay, questions with how I did this problem? So far, I only have one test left, and this is the one that I just do in my head. Turning point test. How many times will this thing turn direction? Should be 2. The reason why we know that, you take your highest degree item, which is 3, right? And you always subtract 1 off of it. So this thing should turn directions twice. So if we look at this, it turns directions once, twice. So it didn't turn twice. Okay, questions with how this one worked? No, it's one of those mental checks, like, am I doing it right? Because if this thing turned like 20 times, I did something wrong. And maybe I factored a part wrong. Okay. Any questions with that? Let's do one more, and then we'll do your kind of work day. I want to do one where it's already factored apart, so you can see that. I'm just going to pick one from the book.
Can we do the leading coefficient test before we do anything else? So that way later on in problems we might be doing it.
Mm-hmm.
Alright.
Let me pick one that's already factored apart here. That'd be good. Read off number 55. Let me get sub here. Alright, okay, so here's my new problem. Okay, alright, we're going to go through all the different steps here for how we're going to do this. And the good news is this problem's already factored apart, so I can already start with the x-intercepts. So we'll kind of look at that, and then we'll try to go through all these checks and stuff. Alright, so read off number 55, please.
F of x equals -3 parentheses x minus 1 squared, and then x squared minus 25.
Like that? Okay.
Oh, this is already wrong. This x squared minus 1.
Oh, that's good. Not a big deal. Alright. Okay. Is that complete? Yeah, that's good. Okay. Now, alright, thank you. Alright, now at this point, we're going to look to see if this thing's factored apart. It looks like it is. There's one more step we can go. What can I factor on that? Difference squares in the back. So this back parenthesis can actually go one more step, because it is a difference of perfect squares. So it's 2 parentheses plus minus x and x, 2 and 2. And I have this parenthesis, which is x minus 1 squared, and I have that -3 up front, which doesn't count. Okay, so I factored this thing completely now, so that's good. Now, let's read off what my x-intercepts are on this graph, because I can look at each of these parentheses and read them off. Now, is there any way that I can make this 0? No. It's not a variable. It's just a number. It doesn't count. Okay? I know somebody's going to say that that makes 0. It's not. There's no x there. There's nothing I can plug in. Okay, what will make this 0? Positive 1, right? And we'll come back to the multiplicity on that one here in a minute. What about this? 2 and positive 2. All right, so we have a couple x-intercepts. So let me put the dots there. -2, positive 1, positive 2. Okay. And multiplicity talks about, am I going to bounce or pass through those numbers? So let's discuss that. What's the power on that x minus 1? Second power, right? So that means I'm going to bounce off of this number. And the rest of the parentheses all have 1s on them, so I'm going to pass through the rest of them. Okay, now, just like we were talking about earlier, like Connor was talking about, he likes to know the leading coefficient test first, so he likes to know where the tails go. He wants to get kind of a rough sketch, so he wants to do this part like one of the first steps. So I just backed that apart, but we need to make sure that we do the leading coefficient test correctly. That way we know kind of what the biggest item is. Now, I'm going to do this by the shortcut, and then I can show you the real process if you want to know. The shortcut that we do here is you take each of these parentheses we got right here, and you multiply the leading number out front together. So there is 4, technically 5 parentheses there. There's 2 here, 1, and this one. Okay, and I'm going to multiply those all together. So I'm going to take this -3. This is the shortcut, by the way. Take the -3 times what's the item out front here? A 1x, and it's squared. So it's 1x squared, right? So I'm going to take that times squared times, what's this back parenthesis here? A 1x to the power, okay? 1x to the first, and the back parenthesis, 1x to the first. All right. So I'm going to multiply these together, and this will be my highest degree item. So even if I FOIL this all together, this will be the first item in that whole thing. It's every parenthesis that you see there, and whatever the leading number is. So you have to worry about squares and cubes and all that. Okay? So this is 1 times 1 times 1 is 1, times negative 3 is negative 3. And then how many x's do I have? 4. Okay, so this is my highest degree term, what's going to happen on front if I were to FOIL it all out. I'll actually have to FOIL it later because I need to do the symmetry test. So I'm going to have to actually FOIL this. Okay, so this would be my highest degree item. Okay, so that means the tails are going the same direction because it's power 4, right? It's an even. So that means the tails are going the same direction and they're going down because it's a negative number. So now the tail's going this way. Okay, does that make sense now? Where my tails are going. They're going the same direction, going down to negative 3. Okay, now I don't have a y-intercept, which is weird. Usually I always do. I don't have one here, so we actually have to figure that out. So doing the y-intercept, I'm going to do my little shortcut like I talked about earlier. Going back to the original problem that they gave me and just plugging in zeros. So take my original problem, plugging in zeros into all these spots, and then solving that out. Okay. All right, so what do we have? We have negative 3. 0 minus 1 is negative 1 squared is 1 times 0 minus 4 is negative 4. So what's going to happen here if we actually multiply this, it turns out to be a positive 12. So that's my y-intercept. I'm hitting positive 12, so it's hitting way up here. Positive 12 on the y-axis. Okay, so now let's go through. I think I can get like a rough sketch what this thing looks like now. I need to bounce off of 1, pass through negative 2, pass through positive 2. Okay, so getting a rough sketch here. So I'm going down here. I'm going to pass through negative 2, go up, hit 12, come back down, bounce off of 1, and then pass through positive 2, and the arrow is going down. So I did draw that probably correct, something like that. I have no idea how tall those things need to be. I don't even know if the turning point is 12, I just turn around up there. I know I hit it at some point. I don't know if it's there, if it goes higher than 12, then it comes back down and hits it. I'm expecting I probably went higher than 12, maybe 13 or 14, came down. And I have no idea how tall this little pipe is.
Sure.
Yes.
Our y-intercepts always pass through.
Yeah. You always have to pass through the y-intercept. Yeah. Good question. Okay. Any questions with the first, basically, 3 tests? Symmetry is the hard one. So that's FOIL had all that messed up. All right. So let's FOIL this mess out. Let's see what we have. We have what is this? It's negative 3 times an x minus 1 times an x minus 1 times an x squared minus, what is that, 4? This is what the original problem was. If I actually, ran it out, I'm going to FOIL these together. What that means? That means x squared minus 2x's plus 1. I'll keep going here. You can FOIL this all out. Negative 3, I'm just going to leave 1 for right now. That's x to the 4, negative 4x squared, negative 2x cubed, positive 8x, 1x squared, and a negative 4, and then multiply everything by negative 3. So if I actually distribute this, this is negative 3x to the 4, positive 12x squared, positive 6x cubed, negative 24x, negative 3x squared, and positive 12. That's FOILing it all out. And now checking for symmetry. Plugging in the negative x's into all of these. and checking what's going to happen here, I can basically tell after the first couple what's going to happen.
Or would you not combine the total scores and then make the predictions?
You can if you want. It's not a big deal because I can check what's going to happen here in a second. So plug in all the negative x's. Yeah, if you want to combine like terms, you can. That might have made it a little bit easier to combine like terms. This negative sign will cancel because the power of 4, so it will stay in negative 3x to the 4th. Negative sign will cancel. And the negative sign will actually stay, and I can already stop here. This thing is not turning out to be the same thing I started with. It's not the same thing that I started with up here, right here. It's not the same thing because that one turned negative. So since it's not staying the exact same, and it's not turning the exact opposite on everything, it's definitely not symmetric. And in fact, I could have told you that. By looking at the graph, look at x-intercepts. X-intercepts aren't even the same spots across the y-axis. But no, it's not the same picture right on the left side. So it's definitely not symmetric. All right, and then turning points. What was my base power on this graph? 4. Subtract 1 off of it. I should turn 3 directions, 3 times. So 1, 2, 3. Yeah, so it turns 3 times. Okay, questions, comments on this problem? All right, here's your homework. Now this homework I'm going to make it due on Wednesday next week. So you have some time to work on it. So if it's not done Monday, no worries. So at least you can enjoy your weekend for once. Not have to worry about stuff. Yeah, and don't wait to start until Tuesday night at like midnight. All right, here we go. Here's your homework. It is page 312, numbers 15 through 18. Now, on these 4, the pictures are already drawn. You just have to match the equation with the picture. So that's pretty straightforward. After the first couple, you'll figure it out. Okay? 48 through 54 evens. These are where you're going to have to factor the problems up yourself and graph it and do all the little pieces. And the last few here, evens, these are where you're they're already factored for you. They're already factored. But again, you'll need graph paper. You do have to graph some of these.
Can we just use this graph paper?
You'll need a new piece of graph paper.
Alright.
You'll need, I think, 8 graphs. So, and I don't want you to use the notes because that way you can feel clean. All right.
Oh, I got you.
Yeah. We're going to use that graph paper more. All right, so here's the graph paper that you'll need. Go.
I'm already in break mode.
I know, right? I
Hey,
just want to sleep.
hey, Connor. Hey, Connor. You got that frisbee I got there, bud? Left foot. Okay, you're right. I don't deserve you to have it back.
One active covers. There's like 12 questions. Alright, man.
You still got your belt yet?
Oh, Tyler. One of these days.
One of these days you're gonna cut
Also, we're just doing the weekly coefficient.
One of these days I'm going to give me some extra $20 for a month. He sends me an email every day. I keep forgetting it. I told him for sure before Thanksgiving break. Tell him, $20. I'll get back tomorrow. I actually will. I gotta get more than $20 for it. I told her if I didn't, I'd start adding interest. Actually, no, I get it. Oh, but I want to actually have this class. Yeah. I get you.
We just did that.
Marcus Wise. The skills like that.
Yeah, we literally just did that.
Oh, I thought, oh yeah, we did just do that. Creativity is more just did it in the.
It's crazy.
I mean, I watched for it, dude. That's how I learned. It's not like figuring like that. I'm thinking I should start spending all that work.
I could have sworn you were right. Yeah.
That was so hard to do. I was so impressed. I was different directions. My arm is actually
Yeah. So it's great.
I didn't expect it to go this way. Like, I was that impressed. I thought this is it.
Yeah.
Yeah, that's enough for today.
Do all 20 then. I'll pick them all up and I'll do it.
We just did it. We actually did two hours.
Yeah, she was a good one for just walking in and just rubbing stuff. Like, he's good at editing stuff, walk in for the keys, perfectly language. But he said, you know, I want to do that. You kind of weird to do that. Well, we only did review coefficients at 15. I saw you go ahead.
How you feel about the game tonight?
No, I don't know what to expect. They're tough in the Ozarks.
At least freezing. Jimmy, no way.
No, that's a huge plus for us.
Getting the feeling
I
of
don't know.
the last one.
I don't know. It's the first game. I never know what to expect.
Negative.
I'm worried about right now. I'm just worried about the game.
I'm thinking about
I'm not saying anything just because I just have a mixed bag.
mixed bag.
I just have whoever's left. So
You get the left.
dude, it's kind of helpful.
Are we doing what we've been doing for the last
I always keep seeing that.
every single test?
That's literally what I'm left with.
A whole 7 yards. Which test are we going to do?
I feel like it's hot.
Where are you writing when you take back? Ethan, you're probably the smartest person I know.
Alright, here we go.
Reading coefficient. Alright, what's test? What test are we do next?
I work until 10.
Did you write, hold on, branch?
You write first part.
No, you write A. A is that, right? So A is, put A and then A.
I watched the movie last night, but I don't remember what I watched.
Yeah, but you went out and then it came up like that.
Why would you do that? Now, are you even in PreCalculus?
It's yours. I'm getting my feelings hurt.
Payback for what you did yesterday.
Yeah, so
What did I do? Oh, yeah.
Oh, yeah.
The fact that you had to say, oh yeah. Not good.
those mean emails you send me, I'm recording that
Yeah,
today.
that would do it, because you will laugh when you're a dick.
Like, who is he on the second track? Who is he now? He doesn't do what you do. Oh, dang it.
Go down.
150. I'll make sure you're 150.
So down, next little finger.
You reaching?
Wait. Yeah, right.
That's when you take out, next when you take out negative 2x. I can't hold on this long. 0, 1.
I mean, I knew everything except yeah, because you said you made us
Alright. Intercepts. Come on, Tyler.
Stratigraphic experiments, density issue, and
Right now you're
issue, and
Symmetry Test.
I just think yeah, that was really good.
Makes that. Negative 2x squared minus 2x cubed. So it's either or neither. Turning point, 3. 3 CP.
That seems
0, 1, and they're both going down. You don't have to. Sometimes it's like it might happen later on. You know what I mean? You have to remember it was 2x.
maybe to not be perfect.
Come on. It's like this.
Yeah, I've been surprised. That's why I just do my gut myself.
There you go, Christian.
Test is like 90% of the work. I just wrote down all the information.
What did you say?
Almost.
What did you say to me?
That's parabolic sweat.
It's just things like
So
that.
air follicle like creates hair.
Got one like that,
And
like-
then the right your pea gland makes your hair stand. Yeah, I know. Pea gland.
What did you draw?
Pili muscle. It's a muscle.
Can you take out an X?
It makes hair. I got my
How can you do that?
Yeah.
Sir, you come here, I'm working. How many, oh, it's kind of guys will come over here. Okay. Yeah.
If I can't try to say my watch. You press over the job.
Yeah, Tyler, you try.
You do it.
Hi.
Yeah, I have two intense.
Oh, I don't know. Oh, that was a bad idea. Why did I do that?
Show one, two,
What is that?
No, I gotta be smart and just do that.
You should just hold on.
You actually, so that you can factor this out. X squared plus 3x. Right, yeah. You're probably the smart person I know. So what do you do? Wait, but then how does that give you a 6? It doesn't give you a 6 and then 6 and 3. But like if you factor this out, you're not going to get a 6.
No, the stress are going to retail.
How about x squared plus 3x squared minus 2? There we go.
What?
Plus 3. Plus wait, that's a minus. It's a minus 2? Yeah. Well, you're trying to get a positive 6.
No, I factored by -1.
Alright. You lost.
Oh,
I factored by -1. So just change it all the time.
Oh, what a smart guy.
Yeah, you go next. No, that way the signs are off. The signs are off. You have to leave it this way, or it's 6 minus x squared.
I'm gonna have to forward it down. I don't know.
Oh God.
What's this gonna do?
X squared.
I'm gonna take the weekend to think on it. That's just imaginary.
Yeah, just take all break and think about it.
X squared plus 3, x squared minus 3, that's it.
And then you should bet it goes 0, that's a negative.
Oh, that's gonna be like the,
How you figure out what makes your
On the back, I got 3 out of 5 in my That's lucky. I tried it, I got 2
Still can't
On
find
what? For what?
Oh, I got so lucky.
He never screwed him.
And I'm just not getting ready for
But still, there's a lot of Saturday. Except, I still practice on that day.
Me too.
So this reward.
So, if we get like a negative square, like imaginary something, or an accident or something, then what?
That doesn't count as an extra stuff. If it's imaginary, don't count.
That's
Bring it up in place.
This one would though, right? This one would count, right? That one? We did it at 1.4.
Well, remember it's a positive.
We'll move that around and we'll walk.
They're gonna get accepted in 3 days.
We'll draw the board first. Make sure everyone knows everything.
So, we get homework?
How much?
Oh,
a lot? Oh, shoot.
$20. You just say $20.
Wait, $20 and you'll do my homework? $20 to be an A class. Deal, deal. I have some business.
I work with that.
I need $20.
But I definitely did for Sam, so I was
There's only one business.
and Vic's birthday. I said, Vic's birthday. Happy golden birthday, Sam. And then he goes,
What's anything?
I'm sorry, I really haven't a clue who this is.
Or maybe 25.